In the previous video, you have been introduced to the world of mathematical modeling. This time, we are going to look at the practical application of mathematical modeling using different types of functions. First application is on transportation fare. As of January 1, 2021, LTFRB formula to compute fare of public utility jeeps is as follows. For the first 4 kilometers of the trip, you will pay 9 pesos. Then, for each succeeding kilometer, you will pay an additional of 1 peso and 50 centavos. In order for us to create a math model, we need to study the relationship between the distance traveled in kilometers and the fare in peso. The distance traveled will be our independent variable x, and the fare will be our dependent variable f of x. The table of values for a 10-kilometer trip is provided as shown. For the first row, as you can see, if the distance traveled is from 0 kilometer up to 4 kilometers, you will only pay 9 pesos. But if your trip exceeds 4 kilometers but not exceeding 5 kilometers, then you will pay 9 pesos plus the additional 1.50 pesos. That is why you are going to pay a total amount of 10 pesos and 50 centavos. If your trip, however, exceeds 5 kilometers but less than 6, then from the previous computation of 10 pesos and 50 cents, you are going to pay another extra 1 peso and 50 centavos. Therefore, the total amount is 12 pesos. This continues, and if you are traveling 9 kilometers, then you will pay this total amount. So that is the relationship between the independent and dependent variables in this scenario. Now we can graph this in our Cartesian plane, and this will be the corresponding graph. And this is a step function. Okay? Step functions can be classified into two. We have the floor function and ceiling function. So for the floor function, this will be our notation. This is also called the greatest integer function. This function gives the largest integer less than or equal to x. So examples, if the floor of 0.5 is equal to 0 because the nearest integer that is less than or equal to 0.5 is 0. Okay? For the floor of square root of 2, that would be equal to 1. Since the square root of 2 is approximately 1.4142, and the nearest integer that is less than that number is 1. On the other hand, for the ceiling function, this will be our notation. And it gives the smallest integer greater than or equal to x. Meaning, if you want to get the ceiling of 0.6, then that will be equal to 1. Because the nearest integer greater than or equal to 0.6 is 1. We also know that pi is equal to 3.1416. And if we want to get the ceiling of pi, that will be equal to 4. Now we can rewrite the given step function model into another form of a piecewise defined function given as follows. So in this function, there are two different values for f of x. F of x is equal to 9 if x is between 0 to 4. Meaning, if your trip is less than 4 kilometers, no matter what that value is, then you will pay exactly 9 pesos. However, for the other value of f of x, which is this one, this indicates that if your trip exceeds 4 kilometers, then you would pay an additional amount depending on the excess number of kilometers. Okay? And that excess payment is given by this equation. Okay? So using this piecewise defined function, let us now calculate our fare. So what is our fare if the trip is 15 kilometers? Okay? So we know that 15 kilometers is greater than 4. Therefore, for the value of f of x, we will use the second one, which is 9 plus 1.5 times the ceiling of x minus 4. Okay? So, substituting the value of x, this is f of 15 equals 9 plus 1.5 times the ceiling of 15 minus 4, which is 11. Okay? The ceiling of 11 is just 11. So we have 9 plus 1.5 times 11, giving us the total fare to be 25 pesos and 50 centavos. Another application of mathematical modeling is by using it in your grading system. The table shown represents the PSHS grading system, which is similar to major universities in the Philippines. So let's say you have a raw score percentage in this range. Let's say you have a raw score average or grade of 85.6%. Okay? In order to compute its corresponding PSHS grade, we need to refer to this table. 85.6 is within this range. Therefore, your grade would be 1.5. Okay? So let's create a piecewise defined function that can model this entire table. So if we let x to be the raw score percentage and g of x to be the grade corresponding to that raw score, then we can plot this one in our Cartesian plane, as shown. Again, this is a step function, and by manipulating the step function, we can have this piecewise defined function. Okay, so this means that there are several possible values of f of x. These are the grades, and you could only obtain these grades if your raw score will fall onto the following domain. Okay? We can further simplify this kasi masyadong mahaba. So if we want to have a shorter version, then this will be the result. Okay? So let's try to apply this piecewise defined function if it models our grade correctly. So let's say my raw score grade is equal to 77.30%. So I want to compute my grade to be shown in the report card. Okay, so there are three options here. So the value of f of x may be this one, or this one. Okay, but ano yung pipiliin natin? So take note, the raw score is our x value, and x lies within this range. Okay, from 60 to 100. Therefore, we are going to use this equation or model. Thus, f of x is equal to 2.50 minus 0.25 multiplied by the floor of x minus 60 over 6. Okay? So substituting x to be equal to 77.3 or 30, this gives us 2.5 minus 0.25 times the floor of 77.30 minus 60, that will be equal to 17.3 over 6. Okay? So using your calculator, 17.3 divided by 6 is equal to 2.8. But then again, we are getting the floor. So the floor of 2.88 will be equal to 2. Okay? So giving us 2.50 minus 0.25 times 2. This is equal to 2.0. Okay? So your report card grade will be 2.0. Next application of math modeling is when we have a population growth. If a population of a town has a relative growth rate of 1% per year, how long will it take for the population to double? So again, we are speaking of population of town, meaning tao, human population. And if the involved scenario is population growth of human, then it is best to represent it in continuous population growth. So the formula that we are going to use is n of t is equal to n naught times e raised to rt. Okay? So sinabi dito that hinahanap natin yung time wherein the population will double. Okay? So find the time t such that n of t is equal to twice the initial population. Okay? So, substituting this relationship sa ating model, we have 2n naught is equal to n naught times e raised to r. So, again, r is given as 1%. That's 0.01 times t. Okay? So, the n naught cancels out, giving us 2 equals e raised to 0.01 t. This is an exponential equation. Therefore, we can solve this. The value of t is equal to ln of 2 over 0.01. Or this is approximately 69.3 years. Okay?